So, now let's start with our first speaker, Shannon Pileggi. Shannon is an enthusiastic statistical collaborator and educator with experience partnering on data analysis in corporate, tech, and government settings. She is currently a senior statistician and Adelphi Research in Doylestown and working in the pharmaceutical market research. Shannon's day-to-day work is in R include fine-tuning ggplots to convey analysis results, contributing to internal package to automate routine analysis of tasks, streamlining workflows for repetitive analysis, and developing Shiny apps. Her today's talk title will be Leveraging R Community for the Job Interview. Now I'm going to stop sharing, and Shannon, it's your turn.
Thank you very much, Chen. Is everyone seeing my screen okay? Awesome, thanks for the signal, Jake. All right, today we're gonna be talking about leveraging the R community for a job interview. Hopefully I hit the pace right as it's a lightning talk. We will be going through it a little bit fast. So this talk is actually abbreviated from another talk I gave for R Ladies Miami in April, which was a broader talk about growing into the R community. And that was also inspired by a blog post that I wrote, a job interview presentation inspired by the R community. So what happened 3 years ago in 2018, I was trying to switch from an academic role to an industry role. And I applied to this position that I currently have at Adelphi Research on December 3rd. On December 5th, I got a phone screen, and on December 17th, I was scheduled for an interview. As part of my interview, my job presentation instructions were to give a 20-minute presentation that focused on market research. That was something that I was innovative and something that I was proud of. And I had never done market research before, and I didn't feel like any of the innovation I had done in my previous academic position in terms of education was really going to be relevant for this. So I had to dig deep to find some new material. During that time frame, David Robinson was also working on Tidy Tuesday, and I was also starting to become active on Twitter. And he tweeted out about a screencast that he did to analyze titles that get claps on Medium posts. And I was like, oh, I've never done that before. That looks interesting. And I watched his screencast. And I started thinking about how I could apply those same principles to data of my own for my market research job interview. As I was thinking about that, I also wasn't quite sure how to present my results. I was thinking about using Sheridan's slides, but I wasn't quite sure if that was the deliverable route that I wanted to go with. So I also tweeted for help the following week, and I got some great advice from Emily Ryder about possibly using a Flex dashboard to give a presentation instead of slides, which I thought was really innovative. So I put all of this together. Here is what David Robinson did. He was looking at Medium articles. The source of the data was Tidy Tuesday. He had this dependent variable, which was the number of claps that an article got, and his independent variables were the words in the articles. He did some exploratory analysis and some more formal analysis in terms of network analysis and a lasso model. And he delivered code on GitHub and a YouTube screencast. So what did I do? I went to Twitter because I was new on Twitter. My employer actually had a Twitter account. So I scraped all of my potential employers' tweets using rtweet. So my new dependent variable were the likes and retweets of my employer's tweets. And my independent variables were the hashtags and the words that were showing up in the tweets. I also did some exploratory analysis with a few new things like trends over time, and I actually had to create new variables from this data. I did the same exact method analysis with networks and lasso models. For my deliverables, I also had R code on GitHub, and I delivered a Shiny app also and a Flex dashboard presentation, but I did not do a screencast of myself live coding this. Of this, what was new to me? Well, I had never used the rtweet package, or what was added on top of David Robinson's material was added was our tweet and some of the exploratory analysis with trends over time, and the Shiny apps and the Flex dashboard was an add on top of Dave Robinson's code. And a lot of this was actually new to me. So I was unfamiliar with Twitter data or the R-tweet package. I had never done a network analysis before or a lasso regression model before. And I was very new to Shiny apps and Flex dashboard presentation. So a lot of it was new to me, but I had that great foundation to work from David Robinson's screencast and his code, which I watched his screencast multiple times. And so it was a huge help for me. And I'll also say that not only did it turn into a great presentation, but it also really helped me do that background research that I needed to do anyway on my employer. So it was 2 birds with 1 stone. So here are the deliverables I gave. There was my Flex dashboard presentation, my code on GitHub, and I had 2 different Shiny apps. One that just allows you to do a basic search on the tweets over timeframes or other parameters, and a network analysis of the words that went together that were associated in those tweets, colored by likes or reads. And I got the job, and I'm still here at Adelphi. What really went well for this presentation was that it mirrored the Tidy Tuesday analysis, or what I did well. I researched do you hear my kids screaming in the back? Sorry if I do. I researched my audience, so I knew to keep it high level and not get too far deep in the weeds of the technical bits. I hosted my presentation online, and I didn't use PowerPoint. I gave them something new and different that they hadn't seen before. What I would have done differently on this was I would have limited the scope of analysis. I went too many different directions. Should I use likes? Should I use retweets? Should I use words? Should I use hashtags? Like, keep it simpler. And something I always do now is I change my ggplot default colors. What I'll say about this particular project is that I knew it was going to be a good project for me, even if I didn't get the job, because there was so much to learn. It provided a really strong foundation for me for different coding techniques, different functions, different packages, and different analytical methods that are now way easier for me to use, learn, and implement. And these methods are right at my fingertips now. So thank you for having me for this lightning talk. If we have questions, I'll take them whenever the moderators say I'm allowed to take them.
Thank you, Shannon. That's really cool. I mean, I have tried to do the job searching, just the passing the Indeed through the HTML, but I never think about Twitter. But this is really cool to give people the new insight about it. So there's one question on the Q&A session. So how did you get the confidence to engage with folks on Twitter? Is it intimidating? Any good tips?
Yes, it is intimidating. I think take baby steps and just try. Like, you're going to have tweets that go out into the world that no one responds to, and then you're going to have some sort of magical tweet that all of a sudden someone might actually catch on to. Like, I guess when I did tweet for help about the share again slides, I did tag some people in the tweet, and I probably wouldn't do that anymore. But even someone that wasn't tagged saw the tweet and responded to that. And so I would say my advice would be, if you put stuff out on Twitter and you don't get a reply, don't stop. Like, eventually you're still going to start getting replies and positive feedback. And then, like, another success story that I had with Twitter was actually designing this graphic that you see on the slide here. That I was a little stuck on what I want to do it. I think June popped in on the thread for me, and I just needed some few tweaks and a little bit of advice, and I just threw it out there and I said, here's my incomplete graphic. I don't like it. Can you help me? And I got like 10 people come back with advice, and it was awesome. So yeah, I would just keep at it.
Thank you. Yeah, our community is always really friendly, and people trying to help each other. That's a really good place to ask questions, I think. So there's a second question for you. Did you research forehead if your company was R-friendly? Wonder if even the non-R folks on recruiting were impressed by your dashboard?
Yeah, so I did get the sense during my phone screen that they were R-friendly. One of the reasons I went in the direction of a Shiny app is because they had told me on the phone screen that they were just starting to explore Shiny applications. So I knew that that was a direction that they were interested in. I did know that in advance.
That sounds good. I think that's all the questions. Oh, wait a second, there's another one. What other R packages do you find useful in your day-to-day?
I use a lot of ggplot, anything that's part of Tidyverse. I'm a huge fan of ggiraf these days to make interactive plots.
All right. Yeah. Great. Thank you, Shannon.
Thank you. Let me see if I can stop sharing, find these controls, where'd they go?
So now I'm going to introduce our second speaker today, Xenia Cherkers. Xenia is Associate Director at the Johnson & Johnson Global Medical Safety. Using R for 15 years, she always worked on better access and the use of multiple disconnected data resources to improve data analysis in less time. She holds a PhD in statistics, master and bachelor in mathematics, and a bachelor in applied mathematics and computer science. Her talk today is Shining Connecting Silos. So welcome, Xenia, and you can share your screen now.
Okay. So thank you, everyone, for joining us in the very warm and welcoming Our Lady's Philly community. I did want to share this kind of journey through different data sources and how to access them. Some of them you're probably aware of, but some of them were kind of hard to get through and get connected to the end analysis pipeline. So the first point that I'm sure everyone is aware of is that we have different, not even data sources, but there's a lot going on in the world. Things that are even reflecting on not just something like a data in healthcare, which my kids also picked this time to fight downstairs, so apologies for that. But what I'm trying to say is that there's a lot going on in the world. There is a lot of different things that are impacting. If we're talking about the prediction, they would be impacting the prediction results. If we're talking about something that is I'm working with, which is medical safety, you can imagine that it spans everything from tox experiment to post-marketing safety. It's very apparent now that we have a COVID vaccine. It is also happening for all the drugs, all the consumer, all the devices, and everything and anything. If we are talking about stock market or tweets that are getting picked up, so there's some news that are happening in the world that if you, for example, combine news feeds with the tweets, you can definitely find something that are getting retweeted more often. So one thing that is apparent is that all these sources that are there, and potentially we can connect to them, but we can't often make them talk to each other. There are multiple tools and resources and platforms that are now becoming available. Our tweets packages is one good example that Shannon showed. Wasn't there before. So there are things that are easier to use and there are things that are harder to use. And I loosely sorted them in this presentation from easiest to hardest, just how much time and effort I had to spend on that. Regardless of that, we all know that if someone sent you a file, you can probably find a way to read that in. But what if it's data that lives outside? So that would be something that I will focus on, just my own personal opinions and struggles and chunks of code that help me to connect to the external data sources. So the easiest one is Amazon. They have a whole slew of tools and a whole slew of data science solutions, and they're very easy to connect to. So something like a database on Amazon AWS. Here, there's a couple of lines of code. All you really need is you need that connection string that is fairly easily accessible, username and password. That chunk of code can extract everything from, say, that my table, that one, and that way you can work with it directly. The next, somewhat easy, is if you have an external Oracle database that is hosted somewhere on the server and you know the location of it, you've got access to it, which is sometimes not trivial either. You do have to jump a few hoops for people to give you access, even for read-only. But suppose you want to run a query. So this particular extract of code will be focused on running a query. You have that Oracle query SQL file. You also have to find the driver, Java drivers that will look like OJDBC, some version number that jar. Once you have downloaded it from Oracle website, you can point to it, point to the location of your database, give it the username, password, and you can run that query and save the results. So that was still not too bad. If those of you who remember, there was a big chunk of time where everybody used Dropbox. The most useful package, and I have to say I haven't used it myself, except for bits and pieces, is that rdrop2. It lets you generate key and secret that you can subsequently use to generate a token, and that is the token that you will be using in any functions that are drop underscore something, or the retrieve or drop it to the Dropbox. So still not too bad. Now Amazon S3 is relatively easy, but here we're getting into little things about where you located, whether there's certain privileges that haven't been given to you to review everything that's in the bucket list. So once you have the key and secret and you know your privileges are okay, that AWS S3 package or library works quite well. I put a link on the upper right corner of the slide because this AWS S3 is under the umbrella of CloudDR. This is a great umbrella for all things cloudy, and AWS 3 is part of it. There's another package I will mention in other slides that is also there. So whoever's working on this are great people. They know what they're doing. Thanks God they're there to help us for art to be more cloud friendly. Now for S3, you need a key, you need a secret. Usually these are the two things that are just as easy to generate as whenever you're working with AWS. And then those are the variables that bucket list function is looking for. Then there's a certain bucket, a certain file. Then it just goes down to whatever you want to retrieve or put in the bucket. Now we're getting into very painful things. Office 360 or Microsoft 365, we are basically talking about something on OneDrive or very painfully on SharePoint. Here, there is a lot of hoops that you have to jump. You have to get access to the nitty-gritty backend of the Microsoft 365 or Office 360. There you need to register your app. You need to let it to be assessed or accessed programmatically. You need to generate that client ID and combination that expires yearly. So this is a yearly exercise. Someone said that it might be done every 2 years, but no one did it. It's like the cheap insurance in New Jersey. Somebody said it could be done, but no one can really get it. And then even though you jump through all these hoops, still on the R side, or Python in this case, I'll get to that in a minute, you still have to get authenticated. Now, I started doing this when that Microsoft 365 R in the Cloud R project wasn't as advanced as it is. If someone used it, it would be great to hear from them, or if someone is willing to use it, we can probably work on that together. But Office 365 was that Python library. It changed a little bit. So there are certain things that had to be adjusted because of transition to Microsoft 365, but there are several steps, and I'm showing the functions in that Python library, which is basically doing the authentication context, acquiring the token, and the client context just explores that SharePoint, in this case, location. And thanks God again for library reticulate. We can source it, copy the file, and then deal with it. Because as I mentioned before, those different data sources are all kind of required. So for example, if you have a non-clinical report that's stored on that SharePoint, you'd want to extract that too. So again, honorary mention from Microsoft 365 R. Hopefully that will alleviate that need for usage of Office 365 Python library. Now the last, technically speaking, Microsoft 365 and Office 360 are both APIs. So that whole process of generating an application and a token, that is their API documentation. So without a very big leap, everything else could be accessed and queried with some sort of a application programming interface, or API for short. How hard it is, it really depends on how they've implemented it. For something like Spotify or Twitter or even Fitbit, got the whole process worked out, where you have the endpoints, you have the authorization schema, you have it all kind of written for you. Some of the newer or locally developed APIs are much harder to deal with. Basically, your two libraries would be HTTR and JSONLite. Generally speaking, you would need either a secret and key or username and password. Oftentimes, there's that extra step that also happens with Office applications to generate a token or some sort of another authorization. If it's not something as well documented as, say, Fitbit or Spotify or Twitter, then you need your specific endpoints. And then basically the two commands from the HTTR library are get and post. If the API has a Swagger, then you can kind of just copy that curl statement and make it with your parameters and call it that way. That's the simplest. Sometimes you really need a good documentation, which no one writes anymore, but at least there's sometimes a Swagger in place. So I think I'll stop here for questions, and thank you for listening.
Thank you, Zhenyang. That's a really wonderful talk. Actually, we are talking about want to ask someone expert on the API to give a workshop and our ladies. Maybe we can contact you in the future. So there's a few questions. Actually, one is from me. This is from my experience when I was making the mentorship, the mentorship Shining app that we are using in Our Lady right now. So when I was using that, I used the AWS3. Do you have to set the file permission to public to all, like public to others or public to all, if you want your Shining app to access the data in the AWS3? Because I have a little bit of concerns at that time that is a security issue there.
You don't have to. It is a little bit, you really have to check all your security like parameters and just make sure that it does what it has to do. For example, you can limit access to a certain bucket, or you can limit it to certain operations in the bucket. So that could be done, but you have to try. I know if the Shiny app is co-hosted with the S3, it usually works better. Whereas if your Shiny app is external, then there's more kind of points where it can stop working.
Gotcha. So yeah, it's kind of a technical question here. So there's another question, is more general. So how do you teach your co-workers about these packages?
The R packages?
Yeah, the packages that you're talking about, like how you teach your co-workers.
It's an interesting question. The R, I think, is great. I really, really like it. There is a lot of things that it does kind of naturally for, I guess, for statistician. One of it is help, how it's organized, how it can be accessed, and how it's documented. The other thing I also feel like R has developed more from a statistical community. It's got much more, even the replies when they come in on like Stack Overflow and things like that, they are more basic. So they don't assume that people know a lot. So that is kind of another thing that's helpful. You can just share a piece of code. That I think is the best way to educate people on workflows and packages and how they're supposed to be used.
Okay, thank you. So there's one more question. Thinking of the Office 365R, any experience with the Power BI APIs?
I haven't used them. I've heard of a talk that uses them. It seems to be still quite painful. I think if the need comes, it probably can be done. It's just, it doesn't seem to be as effortless as some other things.
Gotcha. I think that whoever asked this question probably needed to explore a little bit more. All right, that's all the questions. Thank you, Zhenyan.
Yeah, thanks, everyone.
So the next speaker, it's my pleasure to introduce the next speaker, Jake Riley. Jake is a data analysis and a CHOP and the author of several R packages to improve the workflow of data analysis. His new R package, Headliners, allows users to generate dynamic and informative titles for charts and reports. His talk today actually is about his package development and analytic workflow. Jake, you feel free to share your screen now.
Okay, thank you so much. We're good, you can see? I think so. All right, yep. So my name is Jake Riley. I'm a clinical data analyst at Children's Hospital of Philadelphia, CHOP. Love data viz, love making maps. I use a couple of these tools. And yeah, I've been doing a lot of R package development lately, and I'm going to talk about two of them today, a headliner and this package whereiation. Doesn't have a sticker yet, but it'd be on the screen. So y'all might have seen this chart before. We used it when we did our hackathon with pause. And this was a chart that I kind of came up with to describe, like, kind of look at a dependent variable across all of the columns and factors within those columns. So the stuff at the top has high variation, and we'll have like bigger groups that are further away versus and also outliers. And then stuff at the bottom will be factors that have smaller variation. So the bottom here is gender. There's two groups. So I'm guessing this has binary male, female. And there's not a lot of variation between them. This was looking at how long the animals are in, are at pause from intake until they're adopted. So yeah, so stuff at the top is like high variation with like bigger groups. Stuff at the bottom, the variation is a little tighter. And stuff in between, like it might still have like a wide spread, but the groups are smaller, so it's not as significant. There's not a lot of like heavy stats underneath this. It's mostly a visualization tool and for asking questions. But I just wanted to give a little bit of an update because I know this is a like a plot that some of you have seen before. So although I love this plot, not everyone has been so excited about it. So, but it's now in this variation package, and you can just create this chart really easily just using this plot spread function. I'm just saying the data frame is the pause data, and my dependent variable is end days. So now it's like very easy for me to make this chart anytime I want to look at data. But like I said, not everyone like has an easy time reading this, so I was developing other ways to try to tell a similar story. So one of the built-in data sets in whereiation is the attrition data set, and attrition is just another term for like turnover. And in my data set, I know that there's an overall average of 16% turnover, but I want to know like how there's some variation there. Like I'm sure it's not the same across all departments or all ages, or I think it's like 36 columns in the data set, and which of these are like more interesting to look at than others. Now I could go column by column and make like a pivot table or come up with some ggplot to try to look at this. But at a high level, some of the things I'm interested in are like how big are the groups, and what are their attrition rates? And I can see that there's a lot of variability in the size of the groups, and a lot of variability in the attrition rate. But looking at a table like this really requires a lot of like going row by row and looking through it. It's going to be harder to compare across all of my columns. So I came up with a visualization that looks like this, which I guess is a divergent lollipop chart, but it's telling all the same stuff. So I see the different job levels. The size of the group is the size of the number of people in each job level, and then where it sits on the x-axis is the attrition rate for that group. So seniors have a very low attrition rate. They're a moderately sized group. Directors are a smaller group, but their attrition rate is a little higher than the seniors. Interns, surprisingly, have like a much higher turnover rate, and also are a relatively large group as well. So using this one visual, I can then use the benefits of ggplot and use facets to kind of look at them all at once. So this is a function called plot deltas. So I'm just saying like show me like how different each factor. So within overtime, there's two factors, whether they're eligible yes or not eligible no. And so for the yeses, it's grouped them together and said, okay, well, for all the people where overtime is yes, what's their attrition? For all the people where overtime is no, what's their attrition rate? And then I'm interested in like their delta from the grand mean, which is at 16%. Now, when I look at this though, I see that interns have a high attrition rate. Total working years 0 to 4 years has a high attrition rate. Age 17 to 22 has a high attrition rate. So by just looking at this one chart, I can start asking questions like, are these like correlated with each other? Like these are all like the young folks, like the interns are the young people, are the folks with low work, like fewer working years. It's just a way that I can kind of like start to ask similar questions, or I can start asking questions about, well, why is it that way? Are other variables kind of having those same high values as well? And then because it's wrapped up in this function in whereiation, I can, with very little code, I can just say filter job levels, not intern, and then it just recreates all the plots. So I'm not having to do a lot of manipulation and like writing a bunch of code and trying to retrace my steps. It's just filter out the data and then plot the deltas again. I could really go into all the details of like how this works, and I'd love to at another time, but for right now I'm just gonna kind of move through it, and I just wanted to give the group an update on kind of the progression of this plot that I've been sharing in our different hackathons. There is one more function that I do want to point out though. It's this plot group split, and we've been using this a lot at work to say like, how is our pre-COVID data different from our post-COVID data? Not that COVID's over, but we've ramped back up. Like, are our numbers similar or not? And this group split has 4 different variations. So you could ask a question like, again, this data set has like a binary male-female variable, but I could say, how is turnover in HR different for women versus men? And so the men are represented by the bar and the women are represented by the point. So if the point is greater than the bar, it will be blue. If the point is less than the bar, I mean, it will be red. And so I can just quickly look at this and say, oh, the attrition rate is much higher for women in HR than it is for men. Or I could say, how many women are in research versus men. So this is just total counts. And this has been really helpful at the hospital, saying, yeah, like how is our ED or emergency department, how has the volume shifted since COVID? Like, what are we seeing more of? What are we seeing less of? In this case, this data set is overwhelmingly male, and so all of the bars are red. This is just saying like, what's the volume of the 2 different groups? You could also say like, what's the proportion of the 2 groups? So of all of the female employees, what proportion of them are in research? And that's different than the question of all the research employees, what percent are women versus. So these are like 4 different ways that I can kind of compare 2 groups across a bunch of variables and see where some of the more interesting observations are. Like anytime the bar and point are far away from each other, it's usually something that's worth checking into. Now, whereiation isn't going to write your statistical models and stuff, but it's a really helpful tool for navigating a conversation with my clinical team or stakeholders and saying like, I think there's a lot of variation here. Like, should these patients be included in our project, or I see this over here. Does that make sense to you? And a lot of times it does. They say, oh yeah, that's like a thing. We should probably exclude those patients. But I find this really helpful for engaging with any new data set, and then also just navigating conversations with stakeholders. So that's whereiation. But what I really wanted to talk about is headliner. So the headliner is this new package I'm working on, and it really started with this problem here. So these two dashboards have the same underlying data, but are telling really different stories. So the one on the left, I would say, is really focused on facts. So there's this many applicants. These are the percentages. It's pretty easy to do out of we can do this with like pretty low code. But if there's not like a big actionable takeaway, there's a risk that this dashboard isn't going to be looked at all that frequently. Dashboard on the right, I would say, is more focused on insights. So I think that these are more meaningful phrases. There's a 10% decrease in candidates hired. There's a 20% decrease in total applicants. And if this continues, we'll see a decrease in revenue by 8%. So I think these are more meaningful phrases, but this has a higher risk of technical debt. And technical debt, if that's not a phrase you're familiar with, is like you had to open this in 6 months, or a coworker handed this off to you that they worked on 3 years ago. How much of a headache is that going to be for you to like ramp up and maintain the project? So the one on the left, I think, has lower technical debt, and the one on the right has a risk of high. So let's say we have a chart like this. What would be a good title? So you could just say, callback responses by month. This is just some fake data I made up of like how long it took us to call a patient back. Not real at all, but maybe now that we have fewer patients coming in, or did for at least a while, we can call patients back quicker. That was like kind of the idea of the chart. So we could say, yeah, callback responses by month. It's the same title no matter what the data shows, but maybe I want it to be a little more informative, kind of like that insights dashboard that I had shared. So you could say the average callback time has changed from 32 to 24 minutes. So you could do this manually, which it would just require you to edit it each month, or however often you look at it, or with a little bit of code, you could get it to be dynamic. What would be really nice is if you could get it to say the average callback time has decreased by 8 minutes since COVID began, 24 versus 32. Again, you could do that manually and do it each month, but to get a phrase like this that is dynamic and updates, it could be a very heavy lift and likely a few hundred lines of code to do well. So I think to make charts that make sentences like that, there's a risk of high technical debt. So that's where headliner really comes in. So headliner writes those 100 lines for you. So yeah, it's really focused on informative titles. So if you give it 2 values, headliner is going to populate all this metadata about it. So I say, give me a headline of 32 versus 24. I'll say increase of 8, and then what the 2 values are. I say 24 versus 32. I'll say it's a decrease of 8. 24 versus 3. And if I say return data, it will actually print all this metadata out. So the absolute delta P is like the percentage different. It'll append an article. So like on 8 versus 825. It also will bring a sign. You can also control what kind of language it uses, increase, decrease, more or less, higher, lower. And then there's a shortcut to modify how the original values get spit out if you choose to include them. So we're going to call these talking points. So headliner makes use of glue syntax. So if you've never used glue before, it's like a beefed up version of paste. But if I say my age is 36, I assign that variable, I can use glue and say I am curly brace my age, and then it'll bring back 36. And so if I have this dynamically calculating each day, this glue will just update each time that it's always going to be up to date. I don't have to manually keep track of my. But again, with those talking points, we can use the same syntax. So I can say, tell me the difference between 24 and 32, and I want to say the average callback time has blanked, so increase, decrease, both in the E, so I can just add a D at the end, so trended by delta, so the absolute delta is 8 minutes since COVID began, and then this little shortcut to grab the original. So yeah, with pretty little code, I can write that nice like meaningful sentence that I think is very dynamic, very little code, and I think lowers the risk of this like technical debt. There's just a couple functions I want to call out. So there's this compare conditions function. So you could say, look at my data, and when time frame equals current state, group that together. When time frame is before COVID, group that together, and then aggregate all that. And then that will bring back a list of two values with the 24 and the 32. So I can take that and then pipe that straight into, so I can go from my data frame to compare conditions to headline and get that nice sense. So I do this a lot when I'm making ggplots to give them more meaningful titles. You can also like interact with your data frame. So maybe this is a built-in data set in Headliner, so it's based off the sleep data. I think that comes with the tidyverse. But of these different animals, like how much they spend asleep and awake, and then I added a column just indicating like which one is more, like over 12, they spend more time awake or they spend more time asleep in a 24-hour day. What I want to do is I want to write these phrases like an African elephant spends 17 or more hours awake than asleep, or the Arctic fox spends 1 more hour asleep than awake. So I can write that kind of like grammatically correct sentence using Headliner. So I can use this add headline column. So now I'm piping it off of my data frame, and I'm saying I want to compare the hours of sleep, which is this column, with the hours awake, which is that column. And then I can write a phrase, the common names, that's the field of my data with the animal's name, spends, and then the delta is coming from those talking points I discussed, more hours, and then the more and less columns I'm piping here. So how is hours getting calculated? Because you might have seen it was hours and then hour. So there's this helper function called plural phrases, where you can say, if the value comes, if that delta comes back as 1, write hour, otherwise write hours. And this works for 3 hours, 0.5 hours, but if it's value 1, it's going to say hour. So that's like one of the helper functions. There's also this add date columns function where you can say, look at this column in my data that has dates, and then tell me how many days, weeks, months, quarters, or years ago that date is. And you can give it a reference date to look at. So you can use that compare conditions to say, show me when a month equals 0, first month equals -12, which means show me the current month based in comparison to the same time last year. You can also use the other benefits of glue. So you can like add them together using plus signs. You can reference other variables. So I've made this variable called now, where I've like given it a nicely formatted date, and then I can call it inside the headline. So as of now, attendance has trended up, and then it writes that nice sentence. So that's what I wanted to go over. I know I talked really fast, but I wanted to get through it all. Both of these are currently on my GitHub, and hopefully Headliner will go to Cran soon. I'll put the links in the chat. When you click on them on GitHub, in the right-hand side, there's links to the documentation, and then at least in Headliner, there's an article or a vignette, which will give you step-by-step instructions on like all the different things you can do. But yeah, I'll put those in the chat, and that's what I wanted to share.
Thank you, Jake. There's several questions in one in the chat, I think. So I will start with one of the more general one. Any tips on the good color selections?
Good color selections, or like whereiation or something, or just data viz in general?
Yeah, I think it's probably is asking like what like a color should be used when presentation, I guess.
Yeah, I mean, the focus should always be on like what should the audience pay attention to. So if everything's brightly colored, it's like it's harder to know like what the audience should focus on. So I try to use a lot of gray. I didn't have a lot of gray and whereiation there, but in general, I try to like gray stuff out a bit, and then put the highlight on the thing that's what I want the audience to focus on. And you can control the colors and whereiation with how those plots come.
I remember you have a color package, like simple colors, right?
I do have simple colors. Yeah, that's down here, simple colors. And that kind of creates like that little color palette when you're in like Microsoft Word or PowerPoint that has like that grid of colors. It's similar to that. You can just call them easily in R. Yeah.
So because you presented two of your packages, one person see there's another package called Shining Object. Yeah, the really interesting. What's in the shiny objects?
So I did do a talk on that a couple months ago. Maybe we could
I
point to
remember that
in the YouTube. But that helps debug Shiny without having to keep running your app. You can just do it all locally.
Yeah, I really like that shiny objects because I use it for my shiny development.
Oh, that's great to hear. That's great to hear. Yeah, I use it every time. It's like my go for sure.
Yeah. So you can go to our YouTube channel and to find the corresponding the workshops hosted by Jake. So there's one question. I think you probably already answered it because you said that you put it in the GitHub is about are your packages public available, or you also make packages that are for internal only for your workplace?
So we do have an internal R package that we've built, and we're considering breaking it into two so that we can expose one on public-facing GitHub. The only thing that we don't want to like put out into the public is like how to connect to our database. So that piece, we have all these helper functions. So Xenia showed, these like connection strings, and they can be kind of lengthy. So we have all these helper functions to like connect to the data, write to the data, connect, write the data, disconnect. So helper functions, and then like our color palette and like all of our charts have the same look and feel. You can just add like chop theme onto stuff. We've got like templated our markdowns and flex dashboards and shiny pre-rendered documents that are all ready to go. And so they have like our CSS and our fonts and everything. So yeah, we maintain that internal shop.
Okay. So there's one, actually, I don't know what is a question. It's from Kara on the chat. How do we get the headliners into Chrome like ASAP?
It's on my to-do list. I've been doing a lot of testing with folks. So I've gotten a lot of good feedback from my coworkers at this point. It's in one of our executive reports. So it goes like up to the CEO level folks. And it makes use of Headliner quite a bit. So I've been getting good feedback from that. And now that I feel pretty confident in the structure of how the functions work with each other, I plan to push it to CRAN hopefully like this month.
Okay, good luck with that.
I plan to submit it. I don't know if they'll accept it right away. I plan to submit it soon.
All right, that's really cool. Thank you, Jake.
Thank you so much for letting me present.
All right, so so before our break, we have another 20 minutes, so we can start in another talk from Alice Walsh. So Alice is a computer biologist who studied disease and the molecular level. She is also organizer of Our Lady's Philly and enjoys data cleaning, generating hypotheses from complex data, and mentoring others. Today, she will tell us her experience about the true stories for the scary data.
Awesome.
Alice, feel free to share.
Yeah, I have to figure out how to share, so bear with me. Okay. Does this look correct?
Yep.
Okay, awesome. Thanks, everyone. My name's Alice, and as Chen mentioned, my passion in life and my work is using patient data to understand disease at the molecular level, and hopefully that will lead to us accelerating treatments to patients as fast as possible. I would say one of the things that I like to do is I like to clean data. I really like data cleaning. I'm proud of that. And so I thought I was inspired to kind of give some of the scary stories of the kinds of things you might find in your real data sets and maybe some tips on how to resolve them. This is very surface level, it's a lightning talk, but I would love to talk to people more outside of this about the craziest things they've seen in their data, because I think that's kind of fun. So to start, I like this concept of the data value food chain. So oftentimes we have the joke in data science, like you spend 80% of your time cleaning the data and then the other 20% of the time complaining about cleaning the data. And I think that's from this concept of like, you have this raw data at the beginning and you have to turn it into correct data and then useful data, which is different, and then actually do something with it. And you end up with this beautiful formatted result. So I think that this is actually tying in really nicely this concept with what Zhenya presented as far as getting that raw data, what was just presented on how do we actually like look at that data and format it and visualize it. And oftentimes we consider that earlier part kind of the data cleaning. And that's when you find all sorts of things that you never thought would have been possible in your data. And when you start to plot it, you find that everything is misspelled and that my data is actually in a different language. I had this experience recently at work where we have a lot of different data sets from different cohorts, and it's so exciting, and I get the data and it's in Dutch. And so you go, oh no, what do I do? And so that's where you kind of have to think, this is a great challenge. This is something that's actually a fantastic experience to figure out, how do I use R to clean this data? So one of those examples of what you get sometimes when you look at data is you get free text. So that means there was a field where people could write whatever they wanted. I just have an example here where, you know, you might put your neighborhood in. Some people might say Center City might be capitalized, it might not be capitalized, all sorts of things. Thankfully, there's things like the stringer package, which will let you kind of remove white space, capitalize things, put things in sentence case. It's very, very helpful. I will say that this fails a lot in real data. Something like nephrectomy is very, very hard to spell, including by doctors, which is something that I've experienced. Another thing that maybe some of you have experienced is that Excel kills your data. So this is one that I'm sure that everybody in the bioinformatics community is very familiar with, that actually oftentimes papers and other journals and things, they require that you put some supplemental data in your paper and it'll get put into an Excel file. And the problem is the Excel file will be very, very helpful. And they will take something in a column that looks like a date and it will helpfully turn it into a date, which is very bad if it's actually a gene name. So this is sort of an unsolved problem, that things like SEPT1, which is a gene name, will be turned into September 1st. And that data sort of gets lost. And this is something that now I think actually people are kind of giving up. Instead of fixing Excel, we're going to fix the gene names. And so some gene symbols are going to be renamed to make them less like dates. I think the good solution to this problem is actually to use other identifiers like ensemble IDs or NCBI gene identifiers, but it's a common problem. And I'm sure that there are examples of this across many other fields outside of biology. Another thing you may have experienced is that Excel also kills your data in other ways. So this is sort of a fake example of real data that I've experienced where you might have Excel can be great for data entry or for data formatting if you want to work with it. But if you want to work with the data programmatically, it can be very problematic. So there's comments that you can add in Excel, which are really hard to extract. There's formatting. So something like shading a cell a certain color might mean something like here, you know, the blue cells might be values that are out of range. But when you pull that into R or another format or export it, that information can all be lost. And so I think I don't have a great tip to fix this one. But what I'll say is that one thing that you should think about is, where does my data come from? So like, you know, we know where babies come from, they're not delivered by the stork. Similarly, oftentimes we know where the data comes from. We might be working with another group that's generating that data, and we can come in and think about, is there a better way that that data could be delivered? Is there a different format that we could suggest the data be put into? Is there some automated way that we could put in that could avoid some of these issues that we have with formats that are just not easy to work with? The other thing I wanted to say is just like the #1 tip for working with data cleaning is to constantly be asking yourself, does my data make sense? The #1 thing is always like, should I have this many rows? Do I expect this data to be in a long format, a wide format? Should there be multiple values for each individual, or whatever your unit is in your data set? Are the values reasonable, and are they values possible on planet Earth? So lots of times we find subjects with ages that are 240, that seems unlikely on planet Earth. Subjects who died before they were born, that also seems unlikely on planet Earth. And we can start to figure out, okay, is there something deeper going on with the data, or is this a simple kind of transcription error or something we can exclude? And so I did want to give a few tips for how to quickly identify these sort of errors. So one package that's really great is this package called dataReporter. So in one line of code, I have kind of on the left, you can just use dataReporter, make data report. You can pass in your dirty data, and then the GIF on the right is sort of, this is what automatically gets created, and it'll make a nice PDF report. And it'll tell you things about every variable in your data. Where there are missing values, are there likely outliers? It's kind of like a fancy skimmer if you're familiar with that package. I find it really useful just to look at data and to start to see like, oh yeah, this is crazy. So another package that is similar is this Data Explorer package. And so like dataReporter, in just like one line of code, you can create now an HTML report shown on the right. which gives you information on like, where's my data missing? What's the distribution of the data? Are my data correlated, different variables? Another package I think that's very popular, but I embarrassingly have not used until recently, but once you start using it, it gets really addictive. So these are the three main functions of the janitor package, and one of them is clean names. Oftentimes when you pull in a data set, depending on which package you use to read it in, if you use like read R or just like a base function, your names, like, your variable names are not proper, or they have weird symbols, they have lots of dots, clean names makes them all really nice. It's just nice. And then the other two helper functions that are really great are remove empty for if you have all empty columns or rows. And that's a common, it's a couple lines of code that you can clean up in this way and just start to apply to your data sets. Oh, and then for Excel, since I mentioned that Excel sometimes, kind of can be a pain, I do like using packages to try to like automate the cleaning up of your data with things like openxlsx, where you can set parameters around if you have header values, if you have merge cells, if you have different strings that would be for your missing values. It can do those sorts of things and get your data cleaned up relatively quickly. Another useful function from the janitor package is Excel numeric to date. So you'll find if you try to read in a date into R from an Excel table like this, it will be a number, like 44211, which is not super useful. And janitor will convert that nicely to the date that it was meant to be. So like in that case, 44211, I think is like January 15th, 2021. Okay, final recommendation. This one is a really common one, but it bears repeating because I didn't know about it for an embarrassingly long time, which is using the 4cats package for all the cat lovers around using categories or factors in R. And so FCT lump is a great function. And on the left, you could see, for example, you have a data set, you just want to plot some categorical values as a bar plot. How many times do these different, or what are the values for these different categories? And you often get a plot that looks like this, where you're like, x-axis is a mess. You've got all these different values. You can't see anything, and you can never, ever remember that code to rotate the axis labels. Nobody can ever remember that. And so you get something like this. Quickly, you can use 4cats. So FCT lump and just choose to look at the top variables, and it'll group everything else nicely into this other group. There are also other helper functions in here that are really useful, like this FCT infreq, which will reorder your factors based on their number of occurrences. So then you get a plot like this, which is much easier, at least when you're doing your exploratory data analysis, to look through and start to work with. So it becomes quickly kind of one of your favorite functions once you start working with it. Okay, so that's it for me, nice and quick. I do have some links to some of the things I'll put in the slides, which will be shared. And if anyone has any questions or general, grievances about data cleaning, we can chat about them.
Thank you, Alice. Those are really useful packages for data cleaning. So there's a few questions. So first is the Excel can be read in together with colors. So the bigger question is if it can be automatic for any scenario possible.
No. Yeah, that's the trick, right? I think what it's always hard, especially if you're working with a data set that's going to be like a one-time thing, because then you have to sort of figure out how to hack through it. If it's something where you think, oh, I'm going to be working with data like this multiple times, like I'm working with a collaborator and they're going to be updating this data every month, or we're going to get more data sets from this person, then it makes sense to put in some sort of like data spec in place to be like, this is exactly how the data, we would like the data, and then everything can kind of be automated downstream from that. But yeah, I think working with Excel is still something that I would love to get better at.
Yeah, the Excel is not that friendly for R, I imagine.
Yeah.
So the next question.
Sorry, real quick, I would frame it differently. Excel should make it work for us, not we should make it work for Excel.
I like that.
That's good. So there's another question. Could you clean your data using R exclusively? I found it always hard to just stick with R exclusively while clean the free text data.
So yeah, that's a really interesting question, and I'd like to hear what other tools people are using to clean up text like that they don't like using with R. Personally, I found that I kind of like trying to force myself to use a tool, like maybe it could be Python, R, whatever, do something programmatically. I think for a couple of reasons. One, you get really, really good at R that way, or you get really good at Python or whatever you're using, right? It's really, really good practice to do. And the code that you create for one project is kind of by definition reusable, that you can copy it and use it again and again. And so anytime you can kind of practice doing things programmatically versus any kind of manual steps, I think in the long run, you're going to save time. But, you know, if you're talking about using other tools, not doing things manually, then yeah, I don't see why not use a different tool, but try to do things programmatically.
Gotcha. Yeah, I think it's a really good practice. Like you force yourself to using R. So there's one question actually is from chat, from Jane Young. Any tips on intelligent deduplication, literally especially, no unique ID, for example?
Ooh, super difficult. Yeah, I have done this sort of thing before, but not off the top of my head. I think that's super challenging because you get into sort of some unsupervised machine learning approaches to like identify duplicates. I kind of think that might be a way to go. I guess an interesting analogy, which is probably not relevant here, is this happens sometimes when you work with like genetic data, which is convenient. Like you can identify, you might have subjects from multiple different studies, and based on their genetics, you can, you know, clearly uniquely map that they're actually the same individual who just participated in multiple studies, or by relatedness and things like that. But I think there's an analogy there to apply to other data that you could use some kind of unsupervised machine learning to say with some confidence that there's duplicates.
Someone put on chat is using distinct.
Yeah, but if there are no, if there's no actual identifiers, then you're in trouble. Yeah.
There's another question I don't really understand very well. It is saying what happened to the Dutch data? What is Dutch data?
Oh, I was just saying that example. Yeah, so there you do have to use brute force, right? I don't have an automated way to translate things from one language to another. You have to identify like which variables are the same across the data sets and map them. Yeah.
Gotcha. Thank you, Alice. It's my pleasure to introduce our fifth speakers today, June Choi. June is a PhD student in linguistics at the University of Pennsylvania, where he studied mechanisms of human language acquisition and processing. He enjoys blogging about R and reading about data visualization in his free time. His talk today is about using icon fonts for data visualization. June, you can start to share your screen now.
Is this okay? Can everyone see this?
Yeah, I can see it.
Great. So thank you. Hello, everyone. I'm June, and in this talk, I'll be talking about icon fonts, what they are and how to use them. So we all know what an icon is. We just saw a bunch of them in the last slide, but what is an icon font? First, to understand icon fonts, we have to take a step back and talk about fonts more generally. As some of you might know, fonts can render arbitrary glyphs that have no relationship to the character that you type. So for example, these weird characters spell out the word Our Ladies in Wingdings. Another cool feature of fonts is that a combination of characters can yield entirely different glyphs. For example, in Fairer code, the greater than equal, not equal, and a new base R pipe are each 2 characters long, but then they're rendered as single glyphs like these. And these, by the way, are also called code ligatures. So given these facts, wouldn't it be cool if we could do something like type in the word clock and then get back an icon representing a clock? And you might see where I'm going with this. Icon fonts do exactly that by reserving special character sequences for icon glyphs. So here are 3 icon font families that I'll be showcasing today: Material Icons, Font Awesome, and We People. And I've included links to the websites where you can browse the icon, their license, and where you can find the font files. If you don't know how to use custom fonts in R and don't have experience with that yet, I have links to some resources at the end of the slides, and I'm also open to questions on that. But just know that it's not too complicated, so I hope you give it a try. Now, sure, icon fonts look cool and all, but there are many other ways of embedding icons in your figures. So why would you want to use an icon font versus, say, just importing an image of an icon and just embedding that to your ggplot2 plot? Now, I can list at least 4 reasons why. First is that icon fonts are small in size, and the icon glyphs themselves are scalable, standardized, and treated as text. A lot of the advantages of using icon fonts stem from the fact that, like all other fonts, they only contain directions on how to draw each icon, not a fixed image of the actual icon in pixels. So this gives us a lot of flexibility in rendering the icons. Let me demonstrate a bit of that. Here, we have a simple ggplot2 code with 1 layer, geom text. Right now, we have the word hello as the label, and it has with a size of 25. So we can go ahead and render this, which works as expected. And some of you may also know that there is a family argument to geom text, which sets the font. So if I set the family argument to a standard system font like Calibri, then it'll render the word in that font. Now, how about a custom font? I downloaded Fera code that I showed earlier from Google Fonts, and I have it installed on my local machine. So let's try to render the new BaseR native pipe ligature with that by setting family to Fera code. And then we'll get back the glyph that's used for the, the straight slash and the greater sign. Now, using an icon font is actually not that much different. Remember the clock example? In Font Awesome, the clock icon is essentially a ligature that's produced with the letters that spell out the word clock. So if we pass in clock to the label and set the family to Font Awesome, the specific name here is Font Awesome 5.3, then we'll get back an icon of a clock. What's great about this is that this is still text. We're still rendering this with geom text. So we can have access to all the aesthetics that are related to geom text. So for example, we can pass in a color of red. We can also give it an angle of 30, and we'll get back the clock icon in red that's tilted 30 degrees. And we can also have multiple icons as well by just editing the label. So let's take these aesthetics out and go back to clock. Let's add a bell here. And we'll see 2 icons rendered, a clock and a bell. And importantly, this is still a single GROB, a graphical object. So this is still treated as a single line of text. Now, notice that even though Font Awesome has icons for clock and bell, it doesn't have an icon for alarm. So if we pass in alarm to the text, then it just falls back to rendering the letters individually. But there are many icon fonts out there. So if you really need an alarm icon or any icon, chances are another icon font has it. So in this case, Material Icons does. So we just change the family argument to Material Icons, and we render an icon for an alarm clock. And just for fun, here's what happens if we render the same exact word using the We People font. And here, every letter is a silhouette of a person, which is very nice. Now, let's talk about some use cases. The most obvious perk of using icon fonts is that you can spice up your labels. So here is a very boring chart about social media platforms and my familiarity in them. It'd be kind of nice if we have icons to actually show what each bar is representing. So we can extend our geom text example and just put an icon on top of each of the bars. And this is just by manipulating the Y aesthetic for geom text as a little bit higher than where the actual data goes. And then just rendering the name of the brands with the font Awesome 5 brands. Now, you might also notice that we have the text or the name of the brands on the x-axis. So is it also possible to put icons on axis text? And indeed it is. So if you go into the theme argument of geom text and set axis text x to an element family or element text that's rendered with the family Font Awesome 5 brands, then you get icons in the x-axis as well. And if you're also familiar with GG text, then you can also change the or format the x-axis labels as an HTML span that takes that specifies a color according to the palette of each brand icon, each brand's icon, and the icon itself, and then render with element markdown, and you'll get colored icons as X text. And like I said earlier, all of this happens inline. So these are all treated as a single text object. And in this case, I just have a really complicated title that exploits that HTML tag syntax from ggtext. And then I can render this title that has icons embedded in the title text that's treated as a single text. And this will be very difficult to do if you were trying to use images or embed images of icons, because you would have to have blank spaces first and then try to slot the icons into those blank spaces, and you wouldn't be able to move them together or manipulate them together because they're not the same object. Now, the most exciting part, though, is the fact that icon fonts can unlock new chart types. So here's a very simple example. This is very straightforward. It's a scatter plot that uses weather icons, which adds a third aesthetic dimension without requiring a separate legend, because this is just intuitively telling you what the weather is. Waffle charts are another fun one, where each icon is an observation or a set number of observations. So this allows you to easily compare sizes across groups. And if you've also ever read one of those articles about the decline of public spaces, this is a kind of infographic that you might see, where you see different number of people fitting into a space that's reserved for rows, a bicycle lane, and just an empty public space. So we also see that icon fonts can take us closer to the kind of visualization that professional data journalists use for the general public. And that's it for the showcase. You should check out these other packages that give you more control over text styling that you can use with icon fonts. And for installing and debugging custom fonts in R, take a look at these RStudio blog posts and a Twitter thread that I wrote recently that I'm also working on turning into a blog post. And I'll hopefully be following up with that soon. That's it. Thank you.
Thank you, John. This is mind-blowing. That's the verse that have been repeatedly put on the chat. Not only your content, but also the way that you present. There's several questions for your talk. The first one is, what package did you use to make a slides? Is it interactive? Very cool.
Yeah, so this is rendered in IO slides. It's a slide format that comes with R Markdown and NID-R. And IO slides allow shiny runtime. So this is like has a shiny backend. So that's how I was able to render the plots interactively. It's just like shiny input and then render plot function.
Gotcha. So could you like embed it in the like Google Slides or anything, or it must be local?
Yeah, it has to be local or hosted somewhere that you can also run R from, which is why I couldn't share this very easily. But gotcha. The static parts should be shareable, like a basic, any other HTML file. Gotcha,
that's already good. So for anyone interested in how he made these slides, I think I shared a GitHub in the chat, so you can go to that to find his code. So the second question, can you explain more about the license for those fonts and any issues that might create if you create something with the font? Yeah, so I could go over that a little bit. So I showed 3 fonts there. One was Material Icons by Google. It's completely free for personal and commercial use. Font Awesome is also free, but it has a paid version. And then the We People font was specifically designed for non-commercial purposes. So these licenses also are in the form of like the very general licenses that you might see in other tech products. So there's not like a lot of complications in understanding what they entail. And I'll just say that icon fonts are generally very like open source. You can also find icons from Bootstrap that are also like completely free to use, and you can make derivative works out of them. So I would just double check, because fonts are things that people do as like, or like sell as a product, but I don't think I've come across like non-commercial for pay as often. Gotcha. Thank you for that question. So there's another question. Did you use a special package for the density plot with 110 people, or just the standard density plot syntax with icon font from the ggplot? That was actually just geom text with position jitter. So you can have like, I think I had like 8 discrete points along the x-axis on the same y point
on the same Y value. And then if you say position jitter, then if you have overlapping points, then they like kind of bloat up, and then they like take up the space and disperse.
Gotcha. I probably from now on is going to replace all my dots with icons. They look so nice. Thank you very much. I think that's all the questions. So I'm going to introduce our last speaker, but not the least, Madhavi Ratnagiri. No, Madhavi Ratnagiri. I think that's how I pronounce it. I'm sorry. Madhavi is a research associate at the University of Delaware. She holds a PhD in electrical engineer and master in biomedical engineer. Over the years, she has worked with various types of data, including speech, image, time sequence. She programs in C++, MATLAB, Perl, R, and most recently Python. Today, she will share with you her project identification of a pulmonary dysfunction using machine learning. So, Madhavi, you can share your screen now.
Okay. Hi, everybody. Mine is probably a more technical talk. I don't know. I come from I'm not from the industry, so it's going to be less glitzy. I think I'm sharing my screen. Am I not?
Yes, we can see it.
Oh, thank you. Let me just make this bigger screen. Okay, so this work I had done while I was at Nemours, the AI DuPont Children's Hospital with Tom Schaefer. So what is pulmonary dysfunction? It's basically, discomfort or difficulty breathing because of asthma or sleep apnea. And in some types of these pulmonary disorders manifest itself as asynchronous movement between the rib cage and the abdominal compartments, just during routine everyday breathing. So in the lab that I worked, they had developed a device called NeuRip, which is a modification to an existing device, the respiratory inductance plethysmography. Basically, it has these two straps, one on the chest and one on your stomach. And it tracks the movements of these two compartments. And during normal healthy breathing, the two compartments go in unison, sort of like the graph that's shown here. The two signals you can see are exactly in phase, the red and the blue. But when there is asynchronous breathing due to any pulmonary disorder, then you could have something like this, where you can see that in some cases, they're actually exactly completely out of sync, almost 180 degrees apart. So I think it's obvious that one of the features that is useful to detect pulmonary dysfunction in this case would be to use the phase difference. So if you actually looked at the phase difference of normal healthy breathing, it might look something like this, where you have probably, a glitch here with really high phase angle, but for the most part, it's normal. So the objective of this work was to find an automated approach to use this phase difference feature in detecting dysfunction, so that this device that we call a NeuRip, which you saw earlier, can be used in various environments, with little to no supervision, so such as at home, outpatient clinics, ERs, and etc. So the data that I was given was very small. Basically, it was just data that was collected from 41 subjects. They had all these subjects, sit just in a table on a chair, and then they put the two straps on them and recorded them for 3 to 5 minutes. So there were 10 normals or healthy breathing, and the same 10 people, these were children between 10 and 17 years old, were asked to do a slightly different kind of breathing where they simulated abnormal breathing. So they clasped the nose with a clip, and then put a device in their mouth through which to blow. And the device had just a very small hole. So the sort of restrictive breathing going on. And that's how they simulated the abnormal breathing. And then they had another 21 younger children, 11 younger children doing the regular breathing, and then the 20 neuromuscular patients also just doing regular breathing. So they didn't want to inconvenience, the patients with neuromuscular dystrophy or the young children to do the simulated abnormal breathing. So that's why they just chose the older kids to do that. So when I had this 41 participants, I just decided to use the 10 normal kids with the simulated breathing as the training data and use the rest as test. I know this looks very, if you've done classification and stuff like that, it's usually the other way around. But well, that's the situation we have. That's the kind of data we have. So, and the other thing is the labels that were assigned to this. We know these 10 normal healthy patients are normal. We know these are abnormal. So you have a 0-1 class here for sure. And these we know are 0 again. But the neuromuscular patients, not all of them were known to have pulmonary dysfunction. So that's why we needed to go with some experts. We used about 5 experts and took the majority vote to assign labels to all of them just in case. So we could do inter-rater variability and stuff like that. So what is the best model to use? There are tons out there. What would you use? Given the small data size, so we know there's low variance. So you do the bias variance trade-off. And you know for sure you're going to have most likely an overfit. So you want to use a model that's not very complex and can also generalize well. And I think one of the earlier speakers spoke, Lasso is a good one, but something better is the elastic net regularization. So use the logistic regression model, very simple, and then use elastic net regularization to train it, right? And R is you just use the GLMNet training library and use to train and then predict data, and some of the parameters that were determined, we just did a cross validation to determine what was some of the best parameters to use. Now, if I use the phase difference feature, I got an accuracy of 61%. Not the greatest, can do definitely better. I mean, it's not a very complicated data set. So what do we do? So here's what I did. It was a slight modification to the phase plot, right? Look at the distribution. So here's a parameter that I came up with. It's just simple inverse cumulative %. So basically what it was you take, the phase goes from 0 to 180 degrees. So you take one particular phase, let's take 50 for instance, and then you look at the phase plot and then see how many of the data points have a value greater than 50 degrees. And that's that point. And then you just go ahead and do that for all of the 180 phase difference points. And this is a great plot. So you look at it and you say, the median is 10 degrees. Well, you could have done that, even without this plot. How useful is this? Well, if I put this on, it's extremely useful. So what did I do here? I used the same training and test data. The training data to generate the green and the red plots. Here, basically doing the ICP, which is the inverse cumulative percentage I just told you, for each of the samples or each of the subjects that I had data for. And just basically plotted the normal subjects with green and the abnormal subjects with red, right? The simulated abnormal study. So with this, it's so much more useful and very informative. Just looking at the plot, you can tell whether this person has abnormal or normal breathing, because when you just look at the phase plot, this is abnormal breathing. But if you look at it over 2.5, 2.5 minutes, some doctors or pulmonologists would say, oh, I'm not sure about this. This might just be an anomaly. Some people will go err on caution and say, no, I think, this person might have something going on. But then when you look at this and you say, oh, you know, it's only less than 25 percentile of people have, or time, 25% of the time, the data is abnormal. Maybe it's just, you know, the person shifted a little bit or something like that, and that's why we have these abnormal points in there. So if I use that ICP feature, ta-da, accuracy increases a lot more. And the sensitivity was an interesting thing to look at, because when we looked at the subjects that the DNN did not concur with the human perception or the human assessment, they were actually all normal, healthy people that, you know, the pulmonologists were erring on the side of caution and saying, oh, I think maybe these are abnormal breathing. But the DNN got it right. The DNN said they were normal, while the pulmonologists were saying, maybe this was abnormal, you know, by looking at the plots. So I think overall, the model did extremely well. The logistic regression, and that was sufficient to do this kind of analysis by changing the feature from, you know, looking at the phase difference explicitly and just changing it a little bit and looking at something like a cumulative frequency or distribution. And also it gives a very graphical display. Okay, that's it. Do you have any questions?
Thank you, Melly. So yeah, we have several questions. Really cool. So some of them are really technical questions. Maybe you can answer. I don't know how to answer them.
Sure.
So the first is, how do you handle the labeled data that is subjective? Vote of 5 experts. What if there is a lot of variability, lower confidence in the label?
Lower confidence in the label. I think I understand. So let me say, so the 5 people, we used 5 people and had them label each of them, right? Each of the records. And I just took a majority vote from that. And I also did an inter-rater reliability score. It's called Kippendorf, I think, Kippendorf Alpha. And try to see, you know, which are the raters that sort of correlate better than others. So if there was one rater that was totally off, very different from the others, we sort of tried to eliminate that kind of a thing. But for the most part, I just trusted that these experts, human experts, knew what they were saying, doing.
Gotcha.
The question.
So there's a second question. Probably a little bit related to the first one. So I was wondering how much data you really need for machine learning. Are your 10-ish subjects enough for training?
Never, but it was just very surprising that it worked. So I think the kind of model that you use and the training algorithm you use is critical, and it depends, and that should be a consideration in the data, depending on the amount of data that you have. So whatever data you have, you just don't throw it, you know, into a DNN or an SVM or something like that. Sometimes something very simple as a logistic regression works great, especially if you have small data.
Gotcha. Yeah, I heard the same thing from Carla saying that it is brave to build a model on such a small sample.
Yeah, yeah. I didn't think it would work. But I think it's also, like I said, the features that you use, understanding the trend that is going on and that you're trying to develop a function for, you know, between the response variable and your feature vectors, and trying to change a feature vector and understanding it to fit the kind of modeling that you can use when you have such small data is also critical.
Yeah. There's another question about your work. How did you get into this type of work? It's really cool to apply machine learning to potential help doctors and patients.
Oh, I used to work at Nemours, and he found me. It's kind of, I think, I don't know if this is in all hospitals and research institutions, but nobody knew that I was doing machine learning or I had expertise in machine learning for the longest time, you know. It was after I started talking to a lot of people and saying, hey, I can do this, I can do that, I can do this, that finally this person thought, oh, maybe I can apply this, you know. So there seems to be a lot of gap between the people that can do machine learning and the people that have the data. So it'll be great if people or the institutions could bridge that gap. And I don't know that all institutions do it, but definitely not at Nemours. It wasn't that easy.
So I bet that you learned a lot from your job about machine learning.
Yeah, well, that's where I have my PhD in. So
Gotcha.
Yeah. So what I need to learn is all this cool stuff that you guys, all the previous presenters present.
All right, so there's another 3 questions. What packaging was used for the specificity and the accuracy calculation?
Oh, I just did it in R.
Okay.
Yeah.
So probably just calculate manually yourself, right? Like,
yeah, exactly. I wrote the code, you know, find all the positives, find all the negatives, take the ratio, all that stuff. I don't know that. If there is a package, please let me know.
Okay. Yeah, someone probably can put it in the chat.
Yeah.
So the another question, the ICP phase plot reminds me of the positive portion of 1/x plot. I'm curious to know what happens with the elevated parts in the middle, or is that typical?
Elevated plots in the middle. I'm sorry, I don't think I follow. Let me share my screen again.
Okay.
So I think this is what you're talking about. Is this the middle part that they're talking about, the overlap? Or I don't know.
I'm not sure. Whoever asked a question can put in the chat.
Maybe I can answer another question in the meantime.
Okay. So there's another question. Oh, someone put it there is a 50 to 120 range. Yeah, probably
50 to 120 range. You mean this portion? That's the overlap region. So okay, so if you think about how I drew this, it's basically I took the normals data and the abnormals data, right? And this is basically green and red together. So there is one little portion where there is a little bit of overlap between the normals and the abnormals. So if the data falls exactly in this overlap region, what would it do? I don't know. And one of the things I did try to, and that's the supplement that I put in here, just in case somebody had this question, was when you do logistic regression and especially elastic net regularization, it'll tell you what are the salient coefficients that are important and the ones that it used out of all the 180 variables that were there. It found that it was this portion that was most salient in its decision making of discriminating between the two classes. So just looking in this area and trying to decide, you know, where is it falling? Is it more on the normal side or more on the abnormal side? Will sort of narrow it down a little bit. So it doesn't matter, you know, how much, what happens here or what happens there, but this seems to be very important.
Okay. So whoever asked the question saying, thanks. So he got it.
Okay.
So the last question actually is a joke.
Okay.
Is a logistic regression machine learning wrong answers only?
Okay. Sorry, did you say wrong answers only?
Yeah.
Okay. I guess no then. Yeah, I think there are, whatever you can do, as far as I'm concerned, whatever you can do with classification falls under, or regression, it falls under machine learning.
I guess regression,
yeah.
like 95% of machine learning questions about.
Yeah, I mean, if you open up most machine learning texts, the first thing they'll talk about is linear regression and logistic regression. So I think it is definitely is.
All right, I think that's all the questions.
Okay.
Thank you.
Thank you.
So thank everyone. And today we have heard 6 really wonderful talks, and we're going to make this recording available on the YouTube as soon as we can. And thank you for your attending our events today, and I hope you have a good evening.